Welcome to this explainer. All right, let's jump straight in. Today we're digging into a truly fascinating piece of software engineering straight from the GitHub repositories. We're talking about Jabro. More specifically, we are unpacking the brand new release of version 0.3.1. And let me tell you, looking at the commit history and the review docs, this is absolutely not just some minor bug fix. We are talking about a massive architectural shift here. We're going to explore how the developers literally had to rewire the extension's entire internal plumbing to solve a really nasty problem, one that plagues pretty much anyone trying to run heavy AI models inside a browser extension. It's an incredibly brilliant case study in hacking your way around strict system limitations.
Here is the quick roadmap for our explainer today. 1. Meet Jabro. 2. The service worker bottleneck. 3. The off-screen architecture. 4. Broadcasting state and parsing. And 5. Taming the AI agent. Let's get to it.
Section 1. Meet Jabro, the AI-powered LinkedIn analyzer.
Okay, before we completely open up the hood, what exactly is Jabro? Essentially, it's a Chrome extension designed to analyze LinkedIn job postings, extract all the key information, and then generate a highly targeted resume for you. And looking at the source documentation, it's got a really solid modern tech stack. We've got AI-powered job analysis, direct integration with LinkedIn, a slick React and Tailwind CSS user interface, and it uses IndexedDB for persistent local storage. It's powerful stuff. But as it turns out, trying to run complex AI analysis inside a Chrome extension brings a very specific and honestly very frustrating challenge right to the surface.
Section 2. The service worker bottleneck. Hitting the 5-minute wall.
So this bottleneck highlights a really fundamental friction between how browser extensions are designed to work and how modern generative AI actually behaves in the real world. To grasp the problem, we have to talk about the background service worker. In Chrome extensions, specifically under Manifest v3, the background service worker is basically a traffic cop. It's a script running in the background, totally separate from the web page itself, and it is brilliant at its job, routing messages, listening for events, waking up for half a second to handle quick requests. But here's the catch. It is absolutely terrible at hosting long, complex, heavy computational tasks.
And that is entirely because of this number right here, 5. Chrome enforces a ruthlessly strict 5-minute lifecycle limit on background service workers. If a task takes longer than 5 minutes, Chrome simply terminates the worker. It just pulls the plug, bam, process killed. Now, think about an AI agent trying to read a massive, complex job description, run multiple evaluation pipelines, and then write a custom resume from scratch. That can easily bump right up against or just straight up exceed that 5-minute timeout. When that happened in the older versions of Jabro, the operation was abruptly killed, the UI would freeze up, and reliability just completely tanked. It was basically a fatal flaw for an AI-first extension.
Section 3. The off-screen architecture. Building a dedicated workshop. So the developers realized pretty quickly that they couldn't fight Chrome's service worker rules. Instead, they bypassed them entirely by building what we can basically think of as a dedicated workshop. Here is how the brilliant new flow works under the hood. Step 1. The background service worker goes back to doing what it actually does best, acting purely as a message router and a listener for saving data to IndexedDB. Step 2. It immediately routes any incoming requests for job analysis over to an off-screen document. Step 3. The off-screen document safely takes over the task. And the true beauty of this? The off-screen document is completely immune to that strict 5-minute service worker timeout. So those heavy LLM workflows can now execute uninterrupted no matter how long the AI needs to sit there and ponder the job description. And this perfectly illustrates a massive, necessary shift in state management that had to happen alongside this new architecture. In the old model, the UI sent a request to the service worker and then just sat there, waiting synchronously for a response. It was super brittle. If your connection dropped for a second, boom, the data was lost forever. The new model in version 0.3.1, it's an asynchronous broadcast. It is a robust fire-and-forget system. The UI triggers the task, the off-screen document does all the heavy lifting in its workshop, and when it's finally done, it just broadcasts the result out to the entire extension for whoever is listening. You can actually see this explicitly right in the source code's new message constants. The background worker uses off-screen analyze, JD, to internally bounce the trigger over to the off-screen document. Then, once the AI finishes its marathon thinking session, the off-screen document fires off an analysis complete, or a resume complete message. Both the background worker and the user interface side panel are constantly listening for these exact broadcasts.
What this means for you is that even if you close and reopen the side panel while the AI is still thinking, the UI will instantly catch the result the second it's broadcasted. It makes the entire extension feel incredibly, incredibly reliable.
Section 4. Broadcasting state and parsing. Fixing the HTML parser.
Now, moving logic into an off-screen document definitely solved our timeout problem, but it actually introduced a sneaky hidden danger: content security policy, or CSP, errors. The crucial thing to remember is how Jabro reads the LinkedIn page. It has to take the messy HTML of the job posting and convert it into clean Markdown so the AI can actually read it. Previously, it just used the browser's native DOMParser. But here's the trick. When you run DOMParser inside an off-screen document, it natively tries to fetch all the embedded assets, like random images or tracker scripts found in the HTML. This inadvertently triggers network requests from the off-screen context, which Chrome hates. It immediately flags strict content security policy violations and crashes the script. To fix this nightmare, the 0.3.1 update completely ripped out DOMParser and replaced it with a dependency called HTML-parser2. Because HTML-parser2 is pure JavaScript, it simply reads the raw text. It doesn't attempt to load a single network resource, making it 100% safe for that off-screen context.
Section 5. Taming the AI agent. Preventing infinite loops and crashes. All right, so the architecture is finally stable, right? Well, next, the developers had to build some code-level guardrails for the AI agent itself. And funny enough, we are right back to the number 5. But this time, it's not minutes. This represents a brand new constant they added to the code: max_tool_rounds, which is hard-coded to 5. You see, sometimes an AI agent just gets confused. It might call a tool to read the page, get confused by the weird formatting, call the exact same tool again, and literally get stuck in an endless, infinite loop. By setting a hard limit of 5 tool rounds, the system now forcefully steps in like a referee. If the AI hits this cap, the code completely strips away the AI's access to its tools, forcing the model to stop looping and just give a final definitive answer based on whatever context it has managed to gather up to that point.
But what happens when the AI is running a bunch of evaluation pipelines all at the exact same time, say trying to figure out the salary, the remote work policy, and the required skills, and just one of those evaluators completely fails to return a good result? In older versions, a partial failure like that might take down the whole ship and crash the entire analysis. But version 0.3.1 introduces a really smart philosophy of graceful degradation. The pipeline aggregator was heavily rewritten. Now, if a single evaluator fails, the system just sets a neat little flag: pipeline incomplete equals true. It completely prevents a total application crash. Instead, the system just accepts that things aren't perfect, saves whatever successful data it did manage to scrape together into IndexedDB, and surfaces a localized, polite warning to the user. They even went in and updated the database schemas, making fields like verdict and overall score optional, specifically to handle these incomplete pipelines. It is a massive, massive step forward for the user experience. Let's be real. You would much rather have 80% of an analysis with a tiny warning than a spinning loading wheel that eventually results in a total system crash. Which brings us to a final, really fascinating big picture thought based on everything we've uncovered in this source code today. As our browser extensions rapidly evolve from these simple, single-click utilities into incredibly complex, long-running AI agents, are strict browser architectures like Manifest v3's aggressive service worker limits actually helping us maintain performance, or are they just forcing developers to build elaborate off-screen workarounds to do what they need to do anyway? The Jabro 0.3.1 release absolutely proves that clever developers will always find a way to make the tech work, but it definitely leaves you wondering about the future of browser extension design. Thank you so much for joining me on this explainer. I really hope this deep dive into the code gives you a much clearer picture of the brilliant engineering happening right behind the scenes. Catch you next time.